No, lesson 9.7, factoring special products. So we're still factoring polynomials. So that part hasn't changed, except for now we've just got some special cases. Maybe some exceptions, maybe some ones that just have some special rules. That's what this one is about. So the first one, difference of two squares. Well, first of all, let's review just for a little bit. What is a square? So like the square of 8, 64. The square of 9, 81. Okay? Those are perfect squares because those have roots, square roots, that are whole numbers, that are integers. So that's what a perfect square is. So now that we got that part out of the way, let's just talk about this. Example 1. Factor the polynomial. If you know you've got y squared minus 16, 16 should jump to your head that that is a perfect square. And for that matter, y squared is a perfect square because it's just y times y. And 16 would be 4 times 4. So we've got a minus. Well, whenever it's a minus, then that means they had to multiply together to get that. So if you look at this, it's almost like you're missing the middle term. You're missing just the y. So you've got the first part, and you've got the last part, 16. But you're missing this middle section. Well, what happens when you miss that middle section? It means it must have canceled out, right? So what can you multiply together to get this would be a positive 4 and a negative 4. And what do you multiply together to get that? Just a y and a y. One's got to be a plus, one's got to be a minus. That's how you get the negative 16. So this would have canceled with this. That's what happened to the middle term. It is gone. So whenever you do that, what happens is you're basically taking the square of this and the square root of this and the square root of this. That goes your first terms and your last terms. One's a plus, one's a minus. This example that we got right here. Square of that would be 2x. Square of this would be 3. So 2x and a 3, one's a plus, one's a minus. Square root of this is 5m. Square root of this, 6. Do the same thing, one's a plus, one's a minus. Square root of this, x. Square root of this, 7y. You've got x plus 7y, x minus 7y. Okay. Next one. Let me get all this erased off of here. Next one, factor the difference of two squares. But the problem is, you look at these two, these aren't perfect squares. But you could, they're both even numbers, you could factor something out of there, namely a 2. And if I factor a 2 out of this, so I divide this by 2, it just so happens that I end up with a perfect square. And if I factor a 2 out of this, I end up with a perfect square. So now we've just got a 2 out front. Square root of this, 2. Square root of this, 3n. So we've got 2 times 2 plus 3n and 2 minus 3n. The letters don't always have to come first. I know every time before now they have, but they don't always have to. So if I'm looking at this one, this is a difference of two squares. 4 is a perfect square. 64 is a perfect square. So I take the square root of 4y squared. I get 2y in both. Square root of 64 is 8. One's plus, one's minus. Now, why wouldn't it matter where the plus 8 goes and where the minus 8 goes? Because they're both the same. So, I mean, at some point in time, it's all going to equal out. All right, next page. Maybe. Perfect square trinomial. Perfect square trinomial. So the pattern, right here at the top, the pattern for finding the square of a binomial gives you the pattern for factoring trinomials in the form of a squared plus 2ab plus b squared and a squared minus 2ab plus b squared. These are perfect square trinomials. So let's try some of these. A. N squared minus 12n plus 36. So notice that these now do have a middle term. Okay, they do have a middle term. And where would that have come from? Well, it came from, if this is a positive number, okay, this is a positive number, so what can you multiply together to get it? Will be 2 positive 6s or 2 negative 6s. If my middle term is a negative 12n, that right there should tell you that I needed 2 negative 6s. So you would just have n minus 6 times n minus 6. And this pen is not cooperating at all. It's supposed to be parentheses. So instead of writing n minus 6, it looks much more algebraic just to say it's n minus 6 squared. Okay? Same thing works with this one. Square root of this, 3x. Square root of this, 2. Has to be a negative 2 because they have to multiply together to get a positive and add together to get a negative. 3x minus 2 squared. Next one. Square root of 4s squared would be 2s, because 2s times 2s is 4s squared. Square root of t squared, t. And I am adding, sorry, that's a positive, and I have to add together to get a positive, so I'm not dealing with any negatives this time. 2s plus t squared. Okay, let's try example 4. Factor a perfect square trinomial. And again, just like the last one, well, not the last one, I guess would be example 2. If you look at those are not perfect squares. But again, if they have common factors, you can factor out a common factor and sometimes make them into perfect squares. So what can you take out of a negative 3y squared plus 36y minus 108? Negative 3. If you take out a negative 3 out of here, so divide this by negative 3, divide that by negative 3, you end up with a y squared. Divide this by negative 3, negative 12y. Divide this by negative 3 would be a positive 36. Now, this is a perfect square. This is a perfect square. So I still have my negative 3 out here. The square root of this is y. The square root of this, negative 6, because it has to add together to get a negative 12. Okay, I think this right here, it looks kind of confusing, so just kind of eliminate that from your brain just for a minute. Square root of that, square root of that. We know it has to be minus because that right there tells it's a negative 12y. All right, let's try these couple at the bottom. And then, believe it or not, we are done with this lesson already. So, factor. Square root of h squared, h. Square root of 4 is 2, and notice they have to add together to get a positive, so it's h plus 2, h plus 2. And again, I would always check it to make sure that it ends up where it's supposed to be. H times h, h squared, 2h, 2h together is 4h, and that would give you a 2. Let's try this one. Not a perfect square, so let's factor something out. Maybe a 2. Let's try and see what happens. That would leave us with a y squared, which is a perfect square. Take a 2 out of that, minus 10y. Take a 2 out of that, positive 25. That would get us to a perfect square. So I still have my 2 out front. And that is not really cooperating there, is it? Let's try that again. And what is my problem? I'm just going to go on record by saying it's not me. I promise. Not that you really care or believe me, but I'm just promising it's not me. All right. Enough of that business. Y, multiply together to get that, add together to get that. That means it has to be a negative 5 and a negative 5. Has to be a negative 5 because multiplied together is 25, added together negative 10. So 2, parentheses, y minus 5, y minus 5. You might need to, instead of doing like this, let's make it look a little bit more algebraic. How about h plus 2 squared? This one. How about 2 times y minus 5 squared. Last one, I can factor out a 3, leaving me with x squared plus 2xy plus y squared. Still going to have my 3. And wow, this thing, I don't know, maybe it just doesn't like making parentheses. Maybe it's more of a straight line kind of program today. Let's try one more time. All right, square root of this, x. X over here as well. Square root of that, y. Why? Because it just is. Again, multiply together to get a positive, add together to get a positive. Means it has to be a positive, has to be a plus. So I would have x squared, x 1xy, and there would be another xy. There's my 2xy, and another y squared. That is my answer. If we would like to make this a little bit more algebraic, let's do this. 3 parentheses x plus y. And we are going to square that binomial. 3 times parentheses x plus y. The difference of two squares, pretty straightforward, pretty simple on that part. So square root of one, square root of the other. The key, the tricky part might be to discover whether or not it's supposed to be a plus or a minus in the middle. And again, that middle term will always tell you that. Good luck.